right, so welcome to the fifth beam problem. We have a beam that's pin supported on one end, and on the other end, we have a roller support. What we're going to do is we're going to first we find the reactions, then we can draw our shear force diagram and bending moment diagram. All right, so for a pin support, we have two reactions. We have in the Y and in the X. For a roller, we only have a reaction in the Y. So if you see any beam that has a pin and a roller support, this is a simply supported. Okay, so what we can do is we can write our equilibrium equations to find the reactions. So let's say this point is A and this point is B. So we can write our equilibrium equations, and it'll be sum of forces in the X direction is equal to 0. So any forces acting forwards or backwards, and we can say backwards will be negative, forwards will be positive. And if we look at our beam, we don't have any forces acting forwards or backwards. We only have our reaction. So there are no forces. That means our reaction must be 0. So if we say this is AX, we can write AX is equal to 0. Then we can write sum of forces in the Y direction equal to 0. So any forces acting up or down, up we'll say is positive, down we'll say is negative. So the force that we have is this 15 kilonewtons acting down. And we don't have any other forces. We only have our reactions. So we have a reaction BY and a reaction AY. So we have a negative 15 kilonewtons acting down. We have a positive AY and a positive BY. And this will be equal to 0. And then we can write sum of moments. We can pick any point. We can pick our A point or we can pick our B point. Let's pick our B point. So we can write sum of moments around B is equal to 0. So any moments acting in the anti-clockwise direction, we'll say is positive. Any moments acting in the clockwise direction, we'll say is negative. We have our 15 kilonewtons acting down. So this will be in the anti-clockwise direction. So we can write plus 15 kilonewtons multiplied, and this distance is 1.5 meters. So we can write multiplied by 1.5 meters. Then we have our AY going in this direction, and this distance up to B. So this distance is 5 meters. That's 5 meters. And we're going in the negative direction. We're going in the negative or the clockwise direction. So negative AY multiplied by 5 meters. And we don't have any other forces, so that will be equal to 0. So if we solve for AY, it will be 4.5 kilonewtons. And so what we can do is we can plug in this AY into here, and we can find our BY. So we can write again negative 15 kilonewtons plus 4.5 kilonewtons plus BY is equal to 0. So our BY will be equal to 10.5 kilonewtons. We found our AY and we have our BY. So our AX is equal to 0. Our AY is equal to 4.5 kilonewtons. Our BY is equal to 10.5 kilonewtons. All right, so let's draw our diagrams, and we can draw our shear force diagram. We can draw our bending moment diagram. So we have a positive 4.5 kilonewtons, and we don't have any other forces acting on this beam until we reach our 15 kilonewtons acting down. This will also be 4.5 kilonewtons, and then this will act down. This difference is the negative 15 kilonewtons, and we have up to this point will be negative 10.5 kilonewtons, and this will go in a straight line to the end, and this will go up, and then we'll finish at 0 here. So we finish at 0. This will be our shear force diagram, and then we have our bending moment diagram. So what we know is because we have a constant shear force here, our bending moment diagram with constant increase until this point. So what is this point? Is the area of this. So our area of our shear force is 4.5 kilonewtons multiplied by this distance is 3.5 meters. Multiplied by 3.5 meters, and we'll get 15.75 kilonewton meters. This point here is 15.75 kilonewton meters. And then this will decrease linearly as well until we reach 0. So now we found our maximum moment and we found our maximum shear as well of minus 10.5 kilonewtons. And that's it.